As we gaze into the late night sky from the balcony, we can see a distinctly large grayish object in the midst of twinkling stars. This object seems to be pockmarked by a few dark spots. Nevertheless, it's beautiful and soothing to the eyes. By this point, you've surely guessed that we're talking about the moon. This moon that charms us in the night is our planet's natural satellite. It revolves around Earth in a well-defined orbit. The siblings of Earth, the other planets of our solar system, also have moons. Except for Mercury and Venus, that is. They are the lone exceptions. This is unusual, given the fact that all the remaining planets, from Mars on downwards, have at least 2 moons to their name. Bigger planets, such as Jupiter and Saturn, boast more than 50 moons under their belt. So why are Mercury and Venus bereft of moons? Is there a plausible scientific explanation to justify this apparent moonlessness of these 2 planets? To understand that, we first need to know how moons are formed in the first place. There are basically 3 ways or circumstances by which planets get moons. These are co-formation, capture, and collision. In the first scenario, moons are formed concurrently with the planet. For example, take the case of gas giants like Saturn and Jupiter. When they were being formed billions of years ago, a cloud of gas and debris around them began to take the shape of a ring orbiting the planet. After a while, this ring started to undergo a process called accretion. In accretion, the particles come closer to each other, stick, and merge into a single entity. As the accretion process continues, countless chunks of random debris coalesce together, ultimately taking the form of a sphere and evolving into a moon. The next way by which a planet can get a moon is by capturing one. To understand how a planet can enslave a vagabond celestial body and make it orbit around itself, we need to understand the concept of the Hill sphere. The Hill sphere refers to a region around a planet where it is capable of holding a moon and keeping it in a stable orbit. Many astronomers believe that the moons of Mars, Phobos and Deimos, were captured by the red planet when they transgressed into its Hill sphere from the nearby asteroid belt. Finally, the third possibility for moon formation arises from a high-impact collision. This is probably the nastiest way in which a planet can get a moon. There are many instances wherein a moon was formed from the debris released in the aftermath of a devastating collision. In fact, our own moon is presumed to be formed from one such collision that took place a few billion years ago. Now, let's return to the original question of why Mercury has no moon. Well, Mercury is the smallest planet in our solar system, and also the closest to the Sun. Mercury, like many other planets, was formed from accretion. If that's the case, then why didn't any moons accrete around Mercury? To understand this properly, we need to go back in time. When the solar system was first coming into existence and our Sun was coming to life, the Sun began exuding very strong solar winds that swept away all the lighter materials, such as hydrogen, methane, and ice, into the outer reaches of the solar system. The heavier elements that endured these solar winds were all taken up by Mercury to form itself through the process of accretion. There was basically no material left over by which a moon could have been formed. Even assuming that something was left over, and the moon was formed, it is very unlikely that Mercury could have retained the moon for very long. Remember the concept of the Hill sphere we just explained? Well, the Hill sphere for Mercury is about 175,000 kilometers, which is much smaller than the Hill spheres of other planets. Moreover, even if Mercury somehow managed to grasp a moon or two, any strong gravitational pull exerted by the Sun, in its close vicinity, would snatch the moon away from it. The reasons why Mercury doesn't have moons are pretty much the same for Venus. However, there are a few additional considerations when it comes to Venus. If there is a planet that comes closest to Earth in terms of size and mass, Venus is the answer. Given that it's so similar to Earth in size, and also is not the closest planet to the Sun, it probably has a better chance of having a moon, right? So why is Venus similarly moon-deprived? One of the bizarre things about Venus, from a rotational dynamics perspective, is that it moves in retrograde motion. That is, it rotates in the opposite direction to the rotation of most other planets. Another odd thing about Venus is that it's a very slow rotator. It takes longer for Venus to complete one spin on its axis than it does to complete one revolution around the Sun. Many astronomers theorize that the extremely slow rotation, coupled with retrograde motion, makes it challenging for any moon to have a stable orbit around this planet. So, to summarize, the moonlessness of Mercury and Venus is mostly attributed to their proximity to the Sun. Being so close to our star means that they're not only exposed to a lot of hostile solar radiation, but they also experience the intense gravitational pull of the nearby massive star. When it comes to Mercury, the planet is simply too close to the Sun and too small to have any sustainable gravitational influence to secure a moon in its orbit. As for Venus, its sluggish reverse rotation makes it challenging for any moon to be bound to Earth's so-called twin. If you like this video, then please leave your comments below and subscribe to our channel for more animated stories on the science in our lives. Also, don't forget to hit the bell icon to never miss an update from us.